All right. Hello, everyone again. My name is Vivian Zhang, and I'm from OmicSoft. Now we are a Kaijin company. Today, I'm glad to have Gary Ge from the company here to present to you about some of the exciting and important updates on OmicSoft Land. For today's webinar, we are scheduled for 1 hour. First, I will turn to the presenter for the presentation, and after the presentation, we will have a Q&A session. So please post any questions that you have during the presentation. And at the end in the Q&A session, our presenter will pick up as much as he could. If your question is not addressed during the webinar, we will definitely get back to you with the answers through emails in the next couple of days. All right, now let's get started with the presentation, and I will turn to our presenter. Gary, welcome.
Thank you, Vivian. Hi, everyone. Today's webinar will focusing on the new technology we developed for the land delivery, and also we'll have announcement for 2017 Q1 release for Untitled and DiseaseLand. So it has been almost exactly 10 years since we founded OmicSoft. Jack founded in OmicSoft in Research Triangle Park, and it's still our main campus in the predictable future. And in the first 2 years, we actually have our focusing on softwares only for the client and the server, and based on the user request, we actually curate the data service based on GEO data in 2009. And we also stepped into the NGS field in 2010 with our own alignment and fusion calling algorithm and genome browser. And both OSA and Fusion actually published in 2011 in bioinformatics. And we also have the TCGA data service. So both GEO data service and TCGA data service, they are based on projects, which means that we prepare them as a project, and the user admin actually can download from our side and publish to their servers as a published project, and everyone can search and query using the server's project search functions. However, the data is not systematically curated using like controlled vocabulary, but we try to curate them in a homogeneous way already. It's actually also our good starting point when we actually go to the land stage in 2013. So in 2012 and 2013, before we release Untitled, we actually released on 2 frameworks to support cluster and external script. So cluster will submit jobs. It's actually supporting PBS, SGE, and LSF. External script integration support any command line. It's actually runnable on your server, which means that if you can run GATK and star, you can use an eScript to wrap the command line as a function inside of ArrayServer. So as I mentioned, that in 2013, it's actually a turning point for OmicSoft. We gradually shifting from a pure software company to be content company. We curate the data already in the previous previous 5 years, but we want to curate them in a more systematic way. It's more queryable and more friendly compared to project, because projects actually scatter around, and you still have to click project one by one. In the Untitled, it's more the data and the metadata is curated more carefully, and particularly for RNA-seq, they are running through the same pipeline. And in 2014, we released the Amazon Cloud integration, which allow users to running analysis on EC2 machines for their data on S3. In 2015 and 2016, we released DiseaseLand and GeneticsLand. And it's just in January this year, Kaijin acquired us, and we are now part of Kaijin bioinformatics team, which actually also have Ingenuity, BioBase, and the COC Bio. And we will put some effort to have some integration with other hygiene products. So if you are old user, you may remember that we actually have IPA integration before, but it's actually dropped out because of the IPA is not so stable. And now we're part of hygiene. We are sure that IPA will working closely with us to have the integration plugin back in the ReStudio interface, so you can continue to submit your statistical inference to IPA. So for this year, we primarily with more resource from Kaijin, we plan on the land on cloud, which is already implemented and it will be ready now, and we will plan the ArraySuite 10.0, which is 10 years anniversary release for this in the middle of this year, and end of this year we will have some early access for the land web development to access to access the land through the web, which will actually not so complicated, but it was not so complicated compared to ReStudio interface, but also. But I think it's good for biologists if you only want to query a few genes. It's not going to customize the visualization a lot. And in 2018, we will further improve the web access based on the user interface to make it more beautiful. So before I go to the land, I think on the analysis side, we already allow users to have centralized server for data analysis. And I think around 1/3 of our client actually they have a cluster in backend. So basically they have a ArrayServer running on the submission node, and the submission node and ArrayServer have, based on number of sample you have on the job, it's dynamically queue sub the job and monitor the job and merge the final results into the final data object in your project. And the data can be on your network storage. And on the other side, the server can even coexist with the Amazon Cloud plugin. So you have cluster plugin and Amazon Cloud plugin. Both of them, they can be on the same server. If your data is actually on S3, using the same graphic interface, you select the data from S3 because the S3 bucket folder they actually mapped on a ArrayServer virtual path. So to users, they didn't see too much difference when they go through the ReStudio file browser interface. It's the same folder structure you can see at the network storage or your cloud storage. But if you select the cloud input file, it will actually launch the EC2 machine and running analysis for each samples, one machine for one samples, and it's using SQS message to get all the log to the ArrayServer, so you still see dynamic logs for each machines. I saw users actually running 500, even to close to 1,000 samples simultaneously, and the log is so very big because actually record every samples on every machines. The output will also save to S3, and once all the analysis is finished, it will download small file, the intermediate file like NGS TEX, NGS FAC file. This is a summary intermediate file for each sample and merge them into a data object and in your project, so on the server. So both of the analysis you can see is local and the Amazon Cloud, they integrate to each other. I mean, they can coexist on the same server seamlessly. And on the land side, I mean, it's on the same server you are running analysis. It's also the engine for the land database hosting. You get the public data through our land subscription for land like TCGA, CCLE, and DiseaseLand, and also the patient subject metadata, sample metadata, subject clinical informations. And we also helping multiple companies to build their internal land either as a consulting service or as actually a part of a subscription. We provide some of the support to help build the first land, so the user can continue build using our pipeline scripts. And the idea is that once you have data from your internal and you have the data from public, you can have the data side by side in the visualization using the virtual land integrations. So in the past 3 years, we try to be a central data hub. So which means that we buy a lot of hard drive and downloading the data and processing the data. And for delivery, it seems in the first 1 year actually is fine, but we actually have more and more pressure on the land delivery, especially the last release. We see it's almost, we actually now have 32 land in OncoLand and DiseaseLand. You may not have all 32 because some of the land require strict access, like some of from gene and tech, small cell lung cancer, and a compass for the multiple myelomas. And for those of the land, we have 32, and the total size of the land after publish, it will be 1.5 terabyte. And the total time spent on delivery in last release, we saw 1 or 2 companies, they can finish in 1.5 days. And we saw a few companies actually have to spend almost 5 days. It's depending on the downloading speed and also the machine, whether it's powerful enough, because the total delivery is download the LV and TLV file, those are building block for the land. And once download, it's using your server to do the parallel publishing to the server. So it's, for some companies, it takes 5 days. And some of them actually fail, either lack of storage, disk full in quite close to the end, or they actually have some of the network storage connection issues and it's fail in the middle. So it's some of them, it's a download failed after, although we're even using 10 times to try to download the file. However, there's so many files to download, the possibility is actually high for one of the files actually failed after 10 trials. So there's some frustrations we experienced, and also a lot of pressure on us. And every release we take close to 1 month. We go through company one by one. And if we have access, we help them. If we don't, it's quite hard to troubleshooting. So it's also, that's the main motivation for us to develop the land on cloud. So the good thing on the local is that if it's on the local, it's actually, I mean, it's not depending too much on networks, internet speed. When you query, it's always query from the local, as using multi-thread query from the server local storage. And for some of the land, if it's only a few sample add on, it will be incremental update in the future delivery. And for in the DiseaseLand, it's the philosophy in the DiseaseLand that we are curating the data from GEO and ArrayExpress and a few other public repositories. But however, we don't, there's so many data we can curate. Our priority actually based on users' request, and if a few company request a few data sets, then we put them in a highest priority and put them into next release. However, we promise a quarterly release, but some users, they may not want to wait 3 months to see their data in the land. So sometimes on-demand content update we actually do for a few users is in high urgency, and they want to use the data immediately. So we usually will speed up for some of the project and deliver to them on demand using some script. But still, it's very difficult if we do want to do such on-demand update for and benefit for all users. So The basic idea of the land on Amazon Cloud is actually we have all the land file is already published and built up, and see we call ArrayLand matrix file for each data type for each land. They save on S3 buckets. We actually have 4 different buckets ready. One on east. There's no east on the S3 path because it's actually we think it's default. That's where we are. And the west on the Oregon, and the European I think it's Frankfurt, and Asia I think is in Tokyo. And 4 regions to have distribute, and based on your server locations, it will stream in from one of the bucket for the data. And you still have to create land in order to stream. So when you create, it will download the CFG file, which is a configuration file and sample metadata, and some of other sample set and gene set. This folder is actually empty when you first time create the crossland, and also have the 3 folder for cache as a local cache. So when you query a gene, you will see in the dialog see that it's sync from the cloud for this land, and sync cloud is also sync, then download some file, cache file. It's actually create a cache file on your server. The reason of the cache that it actually will speed up of the later query. For example, you query 2-3 genes, and the other user query one gene actually belong to the 3 genes you queried. So he don't have to sync from the cloud. It will directly read from the cache rather than have to sync from the cloud again. The cache actually have date there, so periodically the cache will be cleaned up based on the date actually they create up. So it's not using your storage too much. So compared to the regular delivery, you have 1.5 terabyte on your server. It actually will, because some of users also keep multiple versions, so they actually expose their storage a lot. I understand in some of companies require the storage increase actually take time from IT approval. And for the cloud delivery, I think it will only download 40 gigabyte for all the OSOBJ. I mean, 40 is actually for all 32 land possible from Uncle and DiseaseLand. And it will expand a little bit because it will insert into a database file. You download a table, it insert into a metadata database file for some such like that. Some of file they download as a compressed file, but in local it will decompress. So it will using 100 gigabyte on your server. So the time of the delivery, as I mentioned, in regular it may take 5 days, but in cloud delivery it will only take 1 to 2 hours for all lands deliver. If you only refresh land like CCLE, it will only take like probably 1 or 2 minutes. The computing requirement that on regular delivery, because I have to after download the building block LV and TLV, I have to publish. For the cloud, it's already pre-published. It's as a streamable data matrix and index on the server. On the Amazon Cloud. So there's no publish is required. It's only need to download those cache file on your server. So for the query, the mode from multiple query to multiple thread streaming from Amazon S3 files. And for future content delivery, it actually will automatically trigger by a version number we change. So we introduce the idea of version control for the land content, and we keep multiple versions on the cloud, and you auto update to the latest version once we release for the production. And for the on-demand content updates, if it's actually there's some of project we want to add into the DiseaseLand, we actually it will durable by version control. Basically, we release a new version and it will, for all users, you will get the latest version. So which means that for DiseaseLand, it's durable. We actually can have monthly release for content updates. So the ArrayServer actually has been improved that it can host both local published land and cloud streaming land at the same time. And just like analysis, you can have local server analysis and also cloud analysis, and also the same data object in the same project. And you can actually still create a virtual LAN, which combining your local LAN and cloud LAN. So it's nothing actually has been changed on the behavior. You can query, you query the data, and also combining data. You're still building your internal data as an internal LAN and combined to the public data. It's streaming from Amazon Cloud. So we actually have a LAN version. Basically, we have the LAN version. We're using LAN name underscore the time we build up, and also the version number we release since this year. And anytime we change the version number, it will trigger the auto update overnight to a new LAN. Basically, refresh your local cache. That's it. And for your local internal LAN, we also honor this version number, and we're actually using the last date you publish to this LAN as by checking the the published history. So you can see that here the TCGA TCGA HG19 test LAN, test HG19 LAN, it's not a cloud LAN, and the version is actually the last year in September. For all of others, we actually have the LAN name underscore the dates they built and the version numbers released. And you can see those version numbers by click help, show the version LAN version. It will open a table for you like this one. When you mouse over to the LAN, it will also show you the version number. So in that way, you actually exactly know when this LAN is released and what's the version number and when they build up. So the timeline that now I already add each of company to have a test LAN visible to all of you. For first release, we want to be careful to make sure every company have Amazon Cloud access for streaming capabilities. I test a few company already. For ones actually I on board as a contractors, I can access your networking environment. So I briefly test, and for companies without proxy, it's definitely working fine. For company with proxies, it works actually for the company I tested. But a few company I don't have access, so you may have to test out yourself. So update the ArrayServer to the latest production, and publish a cloud called test CCLE and the query Fusion to make sure it's working. So if it's not working, please contact us and we can find a way out. Either working with your IT to figure out to whitelist a few of the S3 the link source, or we can think a way using your proxies. And after that, I think we will prepare in next 2 to 3 weeks. We will deliver 2017 Q1 release, which actually all cloud-based. So for a small test, update your server. I think the current server version is 9.0, 9.10. In the LAN tab Tools menu, you will see the OmicSoft Cloud LAN service. You should only see one LAN visible now, but in the future you will see a lot of LAN visible. If you publish them, then you will see on the left side. On the right side, basically the LAN actually available, but you haven't get them yet. So you click this one and send to queue. This is actually the public log, publish log, or the cloud LAN creation log. It's basically download a metadata file and CFG file, and put the sample metadata into the metabase with this MB file, and download a few cache file for dynamic correlations, and it's only take 40 seconds for these small lands. So it's very quick. After that, you can just query. And I didn't actually, this screenshot, it's not based on the test CCLE, it's actually based on the full CCLE. The reason that because I'm not able to capture this progress log for the test CCLE because it's so quick. For CCLE, it's 1,000 samples, so you may see this log for a few seconds. In the log, you will see the sync cross-land based for CCLE, and sync again for for each data type, and then you get the visualizations. Just remember, after you create the cross-land, you have to log off and log in again to see the land visible to you. Just let me know if you have any questions. I can stop and answer your questions. I will check the webinar question section. Okay, there's one question. How about if we want a land with exactly time step for reproduced considerations? So my plan is that I will keep 3 versions. So the previous 2 versions and the current versions. And if you want to stick to 1 version, I can actually fix your company to 1 version forever if you want. So the version control allow me to, it's actually a text file on our server, on our license server based on your server license. I check which region you are looking for and which version you stick to. So it's actually a version control. I think it's pretty good for us. So we bear the cost for downloading and the storage cost on S3. I think we can absorb the cost, but I think the convenience is it's a lot, not only for us but also I think for you. Let me see whether any other questions. Okay, that's the only questions. So for the 2017 Q1 update, for the Oncoland, we actually have the ICGC update from their R21 to R23, and we add a sample from a few other projects. I think for their copy number data, their segment files actually looks better than compared to previous versions. So we can use in their segment mean rather than copy numbers. So you will see continuous values. For the target, we will release target B37 and B38. For target, I think it's first time we release B38. For the OncoGEO, we add a few more projects. Basically, we based on user requests and then our high priority projects, basically a bigger project with RNA-seq data, they have higher priorities. So we add a few more samples and a few more projects into OncoGEO. For the TCGA, we get a few feedback from virus and the bacteria. Alignment and quantifications. Still based on the alignment to the chromosome. Sorry, to the whole virus or bacteria 16As, the sequence. There's still no gene model based quantification yet. Still in progress for the curation part. We may have to contact other vendors to get the accurate gene models rather than the one we actually doing. It's a lot of work on the curation side. I think Kaijin actually can help us on that. We also update the clinical data a little bit. For the CCLE, we get at least 2 feedbacks that our copy number CMV core is not exactly the same as what we get in CBio portal. We actually just upload our CMV segment file to the Broad Institute and to get the logistic calls from their softwares. That's what the copy number calls you get in previously. Since the CBI portal, they also release the CMV course, so we just borrow their ideas, borrow their data, and it will be in sync with them. So you will see identical copy number course, CMV course. For OncoLand 2017 Q1, we also add 3 new lands. One's HPA. It's from the Human Protein Atlas. At this moment we only add RNA-seq data so far. For protein data, we will add in the next release. We also collect the pediatric data sets because I think we get requests for the UCSC Treehouse Trihold Cancer Initiative data sets. But we also curate a few others, so we think it's also pediatrics data, and so it's useful. For the GNA, I think we at least we get 5 requests for this data access. However, this data set, it's actually not allow us to freely redistribute to you. So in order for you to get this land, you will have to request a statement of work. So basically the statement of work is ask us to build up the internal land for you. So I get one question that there are a few lands still in B37. It's the plan that they ultimately will have to transit to B38. I think the OncoGEO, they are going to transit to B38 in the next release. I think most likely in next year, all of them will be in B38. And I think once we transit to B38, they will discontinue in B37. So probably in 2018 or in the end of 2018, B37 will discontinue and all of them move to B38. So for the DiseaseLand update, we get actually multiple requests with project list. It's actually a recommended way, so don't feel that you put a lot of pressure on us when you're sending us a request. It's actually good for us to prioritize those project lists because there's so many projects we can curate. We do want to prioritize based on your need. So I think last release, they are working hard on the kidney and liver disease and also a few of neurological disease because those are actually a few disease area actually lacking in the last release. And so we added them all. For both human and mouse, we add close to 200 to 300 projects. And number of RNA-seq sample also increased a lot. But still, microarray sample still dominates. We also add more comparisons based on the metadata for each project. And here's the pie charts for the project distributions. I think majority is still immune disease and metabolic disease. But you can see that now the nervous disease, system disease actually taking close to 15%. And also the liver disease, although they are small, but they actually, now we actually at least have a few liver disease projects, and they are all requested by our users. From sample side, I think you will see a lot of metabolic disease actually, especially for the mouse, they are large-scale projects. That's why they are more dominant if you check the sample distributions. So there's also some updates from the DiseaseLand. So we finished the DiseaseLand technology framework is ready in end of last year. The DiseaseLand on Amazon Cloud is ready for VCF files. We have still working on the streaming technology for other data type, rather than VCF data. So the technology is ready, and the cloud, the local land technology is ready, and the cloud is in progress. On the content side, I think our TCGA data of the normal sample germline mutation calling is almost ready for, it's actually ready for the exon sequencing data. So we actually collect close to 12,000 normal samples, and we download all the BAM file, and we run GATK on those BAM file to get GVCF file. And we actually do the joint calling across all 12 samples together. So this, I don't think any other company, if you know some other company do the same thing, it's good to know. But it's actually quite resource demanding to do this work, especially for the last step of joint calling. It's actually very, in order to do that, we buy a very big machine with close to 300 gigabyte memory to do that for the joint call. So the result of that, we actually have, we can have two deliverables. One deliverables, we have sample frequency for each variant, for each tumor type. So for example, what is the V600E frequency in, so definitely high frequency in the melanoma, but low frequency in a few others, such like that. So we only give you the frequency of each tumor type. It's more like exact data. You actually can have the population level frequency for each variant. So it can be public because there's no identity information. We also have the sample level variant callings, which means that for each individual TCGA samples, now this normal sample, you have this variant, and we annotate those variant by all the variant annotations we have. And if you have HGMD from the Kaijin bioinformatics subscription, that's a different product. They have HGMD, human genome heritable disease variant, something like that. I've got, but it require you have HGMD subscriptions too. So this one actually have sample level variant information. They are definitely restrictive. So which means that if in order to get this, in order for us to deliver this variant data for you, you have to file co-application with Kaijin OmicSoft, and you also require DiseaseLand subscriptions. And this data is very big. And we are working on the whole genome sequencing data. It only have 900 normal samples, and the GVCFI generate and the joint calling. It's lucky that it's not too many samples for the whole genome. Otherwise, I think this joint call will be, if it's the same sample size, I don't think we have to buy a new machine again. This data set, the joint call result from the whole genome sequencing will be ready for the early access will be in May. We also do the same. We're downloading data for ICGC, so it's the same ideas. Gather the whole DNA sequencing around GATK and call the variant, and then do the joint call and generate a giant VCF files. So one question that we are not using the native GATK. Otherwise, I think we take pretty much 10 months of work, which means that if we run the Broad Institute GATK software, we may take 9 years to get this stage. We're using Sentience implementation. We benchmark that, it's actually identical. Then we run using the Sentience license. We purchase a few licenses from them and running through the whole GCGA data. That's it. I think that's all I want to talk. And there's 4 questions. I already answered 3. There's one question that is there a plan to stop supporting local land installation? So we hope everyone can switch to cloud. If there is a technical difficulty that you cannot switch, then we still have to provide the local installation to you. We don't, as I mentioned, that all your local land, all your internal land are still built up as a local land on your server, which means that we are continue supporting in this way. It's only we try to avoid the effort, the dual effort to build cloud land and also prepare for the local installation. But there's I understand that there's some difficulty that you cannot solve. Then we still support that, because you have subscription. We have to make sure you get the land contents. Okay. Any questions?
Well, thanks, Gary, for your excellent webinar. I think we will wait for a minute or two in case anyone has any questions. If not, this is the end of the webinar, and thanks everybody for listening in. Actually, next month, May 3rd, we will have a new webinar on ArraySuite 10.0, our 10-year anniversary release. So hope everybody could try to join our next webinar. If you have any questions, Gary, I think there is there's one more question here.
Yeah, so for the pediatric, the data is actually it's a microarray data for expression and the copy number data.
All right, I think we will wait for one more minute.
So I think one idea that, as you can see that there's a lot of concerns pop up for the sample level information. You can see that for TCGA data, now all the data actually housed in GDC, and for B38, we see that they have public version of DNA somatic mutation for B38. But if you can download that, you can take a look. You may not able to even see the V600E and the IDH1 mutations. I mean, V600 BRAF mutation and the IDH1, the IDH1 and the IDH2 mutations, because all those mutations, they're not there. And we contact GTC and they said they are still working on that, but at this time they don't want to release, they don't want to bear the risk of release any germline mutations. So which means that they have a extensive filters there before they release the DNA-seq somatic mutation at this moment for B38. I think previously for B7, Firehouse actually released all those map file. So it's quite comprehensive, but in GDC they are not. At least in January, end of January, we contact them, the GDC, they are still working on that. So you will see that in TCG B38, you actually don't have DNA-seq somatic mutations. Unless you actually have a co-application with us, then we will deliver the, you will see the TCG B38 DNA somatic mutations. For B37, you still have that because it's from the Firehouse. So I would recommend you can plan ahead, try to find the co-application with us. It will be beneficial in long run, but not only you for this kind of oncoland data set, but also potential for DiseaseLand. You can also see the germline mutations. Even you only want to see one line of variant across all the normal samples, you still need a co-application with us. So there's one more question that how do you see DNA-seq from TCGA? Do we have to subscribe DiseaseLand besides oncoland? The question is yes. So I think the tumor, I have to double check with Matt, but I believe the sample frequency, which means that for this variant, whether they actually have high frequency in this tumor type, it actually will be binding with Oncolan. However, for the sample level informations, sample level variant information, they will have to be on the DiseaseLand subscription. Oncolan cannot handle that. It's just too big.
All right. I think this will be the end of our webinar. I don't see any more questions. So Gary, do you have anything else to add?
I think that's it. Thank you very much for attending the webinar.
All right. Thanks, Gary, and thanks, everybody. And hopefully to see you next time. Bye, everyone.